starting with COMPREDICT and the virtual sensors themselves. So the big question is, what is virtual sensor? In the end, it's a pure software solution that is running in the vehicle and fulfills the capacities of a traditional sensor. How's it working? It's very easy. We take already existing vehicle data that are running in the vehicle. So on the canvas, there is a lot of information available, and we access these data and then have a data post-processing in two ways. The ground layer is, we call it automotive domain expertise. It is nothing more than physical relations on a vehicle dynamics basis, which give us some kind of robustness for the following data science and machine learning approach, where we use a lot of the vehicle data we gather to bring them into a correlation and to extrapolate these for the creation of such a virtual sensor. The outcome in the end is the sensor itself, which gives us many opportunities in terms of hardware replacement, health monitoring, and digital services. So these services I will jump into later. In the first step, COMPREDICT itself. We just got our new finance round backed by Toyota Woven Capital. And as you can see, trusted by Renault Group. It means we are going into serious production by next year and will be deployed in 10 million vehicles with our sensors, with today's topic especially. And our partners, you can see at the bottom, so we are trusted by the big names in the automotive industry and can continue our journey with them. And again, you will hear it a few times today, we are a fully software-based company, so we only deliver software solutions. What are the application areas of our virtual sensors? So there are three main pillars. It is hardware replacement, so a replacement of already existing sensors that you know in the automotive industry. It is new SDV capabilities, so extra insights into a vehicle that can be realized with the upcoming trend of SDV and high-performance computing in the car. And the topic for today, so the last point in the chain of money making, let's call it like that, it is the after-sales business. And exactly for this after-sales business, we will give you now some more detailed insights into our portfolio and how you can make use of that. So jumping into our solutions, the big question in the beginning is, of course, why you need to introduce after-sales virtual sensors. So it's a big sentence, the warning lights are on. As you can see here, also from a study from 2024, the revenue drop for battery electric vehicles compared to traditional ICEs is approximately 30 to 40%. This is mainly caused by a simplification of the powertrain. So going down from 2,000 to approximately 200 parts, it's just a drastic reduction, which also has impact on the after-sales business. And here the study shows from 700 to approximately 430 euros over a lifetime for one vehicle. Just leads to one conclusion. The tires become a key after-sales driver for BEVs. But as you might know, OEMs are missing real-time insights, how the tire currently looks like. It's heavily workshop dependent and not real-time or in-vehicle deployed. So how to overcome this issue, I will hand over to Christoph, who will go into our solutions.
Yes, thank you, Moritz. So yeah, we heard right now, the problem is really like, or the key takeaway here from last slide was like tire and like all the components, the replacement of components are key factors here for after sales. And we want to change this problem of not having data available about the current state of these components. This is why we are introducing tire wear and brake wear to you today. The idea here is that these two algorithms will give you detailed insight live insights about tread depth of the tire and about the condition of the brake pads and discs in real time within the car, and also giving you a prediction into the future of when this tire or brake will need replacement. For this, there are three main important facts I want to give you. First of all, it's super important to be highly accurate. This is clear. This is why our algorithms have like industry-leading accuracy to predict. So first of all, to know the current state accurately in the car, as well as to predict into the future accurately. Further than this, it's super important, of course, that the solution cannot cost a lot of money. For this, we only use a software-based approach. So we add no additional hardware. Everything can run with all the information available in today's cars. And thirdly, of course, this is like super important that we are independent of what kind of components we look at least in terms of brands, in terms of types. So this algorithm really works for all the different tire types and brake and pad, brake disc and pad types and materials. But I could talk all day long about what benefits we have. We all know usually what's the most important is concrete information. And this is why we show you some accuracy demonstration data on tire wear and brake wear. And first I want to start off with tire wear. So here I want to show you some real life results from our validation project, from one of them at least, let's say it this way, where we gathered 5 tire sets or data from 5 tire sets on different cars, one rear-wheel drive sports car, one front-wheel drive electric car. They had different tire drivers to also change how the driving behavior is done in the data, as well as variation in the way it is driven and or in which underground we were driving and what kind of road conditions we have here. Also, we, not we ourselves, but during the test, obviously different weather conditions were tested and observed. About the accuracy, you will see in a minute. I will show you now a plot where you can see the data, because graphs usually tell a very different stories than just numbers. You see, we started in 3 different kind of areas. We first had a test track where we tested very, very different settings on the tire. So we had pressure variations, we had some information, different undergrounds and so on, to really see what kind of factors influence us and see that it's stable in the prediction. Further, we had then tests on public roads, so to simulate actual customer usage and to see also that the algorithm is robust as it needs to be. And then we went one step even further and said, like, okay, this is nice, but how is it behaving under extreme conditions, like track days? So really racetrack driver with really sporty behavior. And even here we see massive increase of wear and still good accuracy even under this edge condition. Yes, so this is really something where we achieved a 0.4 millimeter RMSE. And you can see we are almost all the time within the bounds of the reference measurements, which has its own inaccuracy, as reference measurements in thread depth are bound to have uncertainties as well. Okay, then on the second car, which is an electric car, we also did testing, mostly here on public roads, where we also observed that we are very well within the 0.4 millimeter RMSE. The second demonstration results I will talk about or want to talk about is the brake wear. So here as well, we did a validation project where we gathered data from two different brake system sets on a rear-wheel sports car, again, with different drivers, high variations of driving and road conditions. Again, the plot tells more than numbers, so jumping to this one, we see here as well that we varied like a different underground, different kind of braking maneuvers, open road usage as well as track usage, where we have a quite good accuracy on the first brake pad. But obviously, we also wanted to check how it works on the second brake pad. So, and it was worn, so we needed to change it. And we see there is some information here that it is super accurate, independent of which kind of brake set we're using. Further, in the rear pad, you can also see that over 3 millimeters of wear, we have quite a good accuracy of 0.14 millimeters, and on the front of 0.18 millimeters. Yes, so you see the algorithms are robust, they are accurate, but how do you use these algorithms actually? Moritz will tell us.
So the big question, of course, is how you as an OEM can commercialize our solutions. Just having the information in the car, yes, of course, it's nice for the driver, but what's the benefit in the end? So you can see on the bottom left, the virtual sensors are operated in the car. These collect data, let's say, measure the tread depth and the brake conditions and send these data to a cloud, mainly owned by the OEM, because these are customer and OEM data. This data then is used mainly by the after-sales departments to analyze the customer driving behavior, to analyze the usage, and then they can also use it to propose and to promote certain products based on the usage of the car, of the driver. And then, of course, the main target, as you can see in the middle at the bottom, that the end customer spends his money again on products originated from the OEM. So really where the OEM has a certain margin on and not on a third party. How this can look like, you can see in our approach. This is just a sample how it can look like in an UI. So you start traditionally with a real-time wear monitoring, where you give out the data, how the situation on your tires and brakes actually look like. So as you know, for example, for tire pressure, you can also have it then for the tire and brake status with a remaining tread depth and an estimated lifetime of each component. Based on that, the best way is to have a predictive forecasting on the current driving style. As I already said, we have a driving style analysis in certain categories. And based on this driving style analysis, you can send out a forecasting. If this forecasting is done in vehicle or in the cloud and just the data is then sent to the car, this is an individual approach and depends, of course, on the vehicle architecture, on the cloud architecture, but both ways are possible. And here you can see the red line clearly states the driver is a sporty driver, and if he continues his way of driving, he will have worn his tires in approximately 4,000 kilometers. But if you indicate to him that he should be a little less sporty and be more, let's say, responsible for his maneuvers, it can be extended for up to 18,000 kilometers. So you also can, let's say, train the driver for more, let's say, renewable driving styles. Of course, once a critical limit has been reached, the idea is to send out proactive notifications. So really, before a tire change, a brake change is intended, you can send out an indication in the UI or on the cell phone or the way you as an OEM prefer that the driver shall contact a workshop to change the tires or the brakes. And of course, you can give out how many kilometers are still left. Typically, we recommend to have at least 1 to 2 tank loads until such an appointment shall be made to not be as time critical as it should be. And based on this notification, the actual after-sales process really starts. It can be in vehicle or, let's say, off vehicle, but based on this analysis, you can promote your components. For example, based on the driving style sporty, you can say, okay, it's a sporty driver. We recommend a sport tire, but if we know it's a more optimal or money sensitive driver, you can recommend a lower cost tire based on the style, and you can increase the bonding of the driver to your dealers, to your workshops, and of course increase by this way the revenue you can generate instead of going to third-party facilities. Having the look at our solutions and how you can realize it, I know that you will most probably have a lot of questions for details. Of course, there are many details that have to be aligned in a direct way. But for the hottest FAQ we regularly get, we want to give you the answer right now, because then I think a majority of the questions is already clarified, and in the next steps, these don't have to be brought up again. So handing again over to Christoph, will answer these FAQ.
Thank you, Moritz. Yeah, virtual sensors is usually a topic which there's a lot of questions. It's a new technology. How do you use it? And from what you just said, like we have lots of discussions with different kind of key players in the industry, and we learn obviously which questions are most pressing. So we try to answer them here right now. So first question, usually we get like, what kind of data is required to run a virtual sensor? Can I use this virtual sensor in my car? The answer here is like, we use really just readily available CAN signals, like wheel speeds, accelerations. They are 99% available in your car. We are super sure that you can get it running in your cars. Of course, upon request, we can give you a list of required signals, split into required and optional signals, as well as parameters. Then usually another question is, at what kind of sampling rate is our virtual sensor running? Usually here we say 10 to 100 hertz are required to have like this really good accuracy of 0.5 millimeters. Lower frequency is also a possibility we can discuss, obviously with trade-off in the quality of the results. Yeah. Then the next question, what technology is used to create virtual sensors? Do you use machine learning? Well, our virtual sensor solutions, as Moritz also already said also in the beginning, they are really a mix of physical approaches and machine learning approaches. So this specific use case here is not very heavy in CPU load. So don't worry, this is not machine learning based in terms of this technology, but the way rather we develop those virtual sensors use this knowledge of machine learning quite heavily. So don't worry about the load on your ECU. And basically what this enables us to do is really to calibrate very, very fast at COMPREDICT for your fleet. Okay, so for your cars, this is not. Then the second set of questions, where's the virtual sensor running? Also a very important question. Everything is possible with software, but we really recommend that we go with virtual sensors into the car using all this high sampling rate available signals and compute the where over there because data is available and transfer costs are low. And then this very enriched data can be put into a cloud if needed for all the after-sales department usage that we just mentioned. And as I also said, there's not a high load on it, so no additional ECUs or something required. You can put it onto the ECU you want to do. The next question is here, is the virtual sensor robust to environmental factors, temperature, surfaces, road conditions? Of course, super important that the virtual sensor is running in production as intended. And I can only assure you that we are robust in terms of temperatures, in terms of other influencing factors. We tested in various countries, different surfaces, temperatures, water conditions. Everything is kind of tested. Otherwise, we wouldn't have also a serious contract as we have it right now. Then, how does the virtual sensor licensing work? Here it is for us important to share that this is really a value-based pricing, a license-based pricing, where we say that, like in typical software sales, the OEM will retain 80% of this incremental revenue generated. So I don't want to go into detail on this because next slide, I'm going to talk about this more. So let's go over to next slide. So the next topic is, what can you take away? And I spoiled already a little bit what I'm going to talk about. What is really important here is that the virtual sensors are an innovative software feature, and that you can boost your after-sales revenue. Okay, so this is the main message we want to convey in this webinar. For this, we can talk about money generally, but again, concrete information is always more valuable. So we brought you a real life sample business case where you can see that the running costs, split it into running and one-time costs, are comparably low with in comparison to what you can generate as revenue. If you take these numbers, you get to a return of invest of over 500%. These are all numbers per car, right? So this is a huge opportunity as well for you to increase your revenue in your after-sales business. So with this being said, to summarize, 500% return of invest with our tire wear, brake wear algorithms, running in real time in the car, no additional hardware needed. Forecasting is possible at very, very high industry-leading accuracy. If you have one question, if you have some facts you want to remember of this, this is the slide that you should take away. And we are obviously very happy to talk to you, but I think, Moritz, you will talk more about this.
Exactly. So big question now is, as you got a lot of impressions how after-sales solutions with virtual sensors can work or will work, definitely series proven. I can simply say, get in contact with us, discuss your application areas, your ideas, your solutions, or that your intended solutions with us. You can see our contact data here on the slide. The QR code for LinkedIn is also working. So you can get our latest updates where we are present, also on fairs, on conferences, right via LinkedIn. We do regular posts, but of course the, let's say, traditional way of direct contact is always working, and we are happy if you get in contact with us, if you have ideas where you want to introduce our virtual sensors in your vehicles, in your ideas, then let's discuss these. And of course, as I introduced in the beginning, this is just the start of our brand new webinar series. We will have 2 more, one in October and one in November. You can directly register via the QR code for each of these events. They will again be held via Teams at the same time. It's always a Thursday, so in 5 weeks, and then again 4 weeks later, we will have our webinars, once for hardware replacement, as you could see in the 3 pillars we had in the beginning, where we can actually replace traditional physical sensors in the car by software solutions. And then the 3rd webinar, where we have a deeper look into our so-called new SDV capabilities, which, let's say, represent the highest evolution of virtual sensors, which are heavy machine learning based, but give you the highest insights into your vehicle and the most valuable approaches you can get with our solutions. Saying that, I want to thank you for your participation. Last words from Christoph.
Yeah, thank you everyone for joining. Happy to see you, happy to hear from you about all the tire and brake wear related informations. I'm very happy to see you in first contact meetings or on fairs soon.
Thank you.
Have a good one.